The timeline, I'll just quote from the recent October 12th suspension termination memo, was all operators are required to have the workplace safety rule programs in place within a year. Obviously, that's a pretty tight timeline. I'll also be following and take a look at the final wording that comes out when it's published in the Federal Register. Potential requirements are also, they had identified that there'll be, as part of the rulemaking, a potential for requesting independent third-party verification of the operator's SEMS programs. This is identified in the September 30th press release. Again, how that'll come into play and the exact nature of that will still be forthcoming. However, it looks like what they wanted to build in is a method to catch problems, identify if there are any deficiencies so they can be corrected. So again, today's focus is the workplace safety rule. But before we get into that, I'd like to talk to you a little bit about putting a perspective on the various safety management systems that are out there, and also some of the overlap in the regulatory arena. For offshore safety management systems, by the way, again, safety management systems is a general term for programs like SEMS and SEMP. For offshore facilities, and for onshore facilities, programs like PSM and RMP. So there's a lot of range of guidelines out there. Internationally, the more extreme requirements are things associated with safety cases that have embedded with it safety management systems and a lot of the key features that are associated with the current SEMS ruling. On the lower end of the effort, which is more of the classic performance-based safety management system program, is SEMP, the API recommended practice that's being translated into SEMS that's now a requirement. Again, there are 13 primary elements. Just to look at those real quickly, this is a handy chart. I'm not going to go into a lot of details about the elements themselves. We've covered that in previous webinars. Anybody who needs to get more information on those, get copies of the API recommended practice, get any guidance or any support on how to approach these kind of things efficiently, please give us a call. That's no problem. And also, we have our previous webinars recorded. If you'd like a link for those, please feel free to request that from anybody in the office. And those are also on our website on our outreach page. Okay, so the general SEMS and SEMP elements, general provisions, safety and environmental information, things like P&IDs, hazards analysis, things like a classic has-up study approach or a what-if study, and also understanding whatever is needed with respect to consequences, management of change, if there are changes at the facility, how to manage them safely, operating procedures, developing those, and also maintaining them on a periodic basis as changes occur at your facility. Operating procedures, we covered operating procedures, safe work practices, training, mechanical integrity, basically making sure the equipment works as designed, pre-startup reviews, emergency response and control that includes your emergency action plan, as well as other physical means of controlling emergencies. Incident investigation, should something occur, auditing these elements to make sure that the program is functioning properly, basically giving a barometer on the health of the program to make sure things are working okay. This is the area that's likely to see further rulemaking with respect to the independent third-party audits that were identified in the DOE MRE documentation. Notice that some of them are in red. SEMS, Safety and Environmental Management System, is not a brand new program. It was streamlined. The proposed ruling that had existed out there before 2010 had a number of key elements in it that were streamlined, hazard analysis, management of change, operating procedures, and mechanical integrity. These are things that had existed beforehand, and it's been greatly expanded, of course, to include the other SEMP elements. Please recognize that there's a lot of overlap in these key programs. What you see on the screen, the yellow area are PSM programs. The orange is risk management programs. The blue is Safety Environmental Management System and also Safety Environmental Management Program. Those are significantly overlapped with a lot of these key elements. Managing safety, or the idea of a safety management system, is not a new idea. The key elements really haven't changed much in several decades for the facilities, the onshore facilities, and also for offshore. The SEMP program's been around for some time too. A lot of these requirements, the key elements of the program, are pretty much tried and true as recognized mechanisms for managing safety. The overlap area is the area that you see on the screen in green. So what I'd like to focus on is how do you approach these programs effectively. We've provided overviews on past webinars, background on what kind of these elements need to consist of. What I'd like to focus on today are the things that can trip you up, the things that people tend to not get around to, not get done properly, and get mostly cited on, or people finding deficiencies with their program. The first thing is the fact that these are evergreen programs. It's not something where you just do once, put it on a shelf, and you're done. So they require periodic upkeep. These upkeep requirements, with each with different frequencies of being updated, depending on the importance of the SEMS element, these are things that a lot of people have trouble keeping up with. Days go fast. A lot of people are wearing multiple hats, especially in today's business climate. So it's really easy for things to fall through the cracks, and they do. For the SEMS program, the things that are classic things, well, these are the key periodic requirements that people have to keep up with, that are tough to keep up with. If you've been following SEMP and been endorsing that, the hazards analysis is a key part of that to understand the nature of the hazards that exist at your facility. Every 5 years is the baseline for how often those hazards analyses need to be updated. If it's a low priority facility, if it's a low hazard facility, you might be able to get away with 10 years. But whatever you choose in terms of the period of update based on the importance of your facility, you need to document and justify that. It's not something where you just want to arbitrarily go like, oh, this is a good year, let's go ahead and update our hazards analysis. You want to have it driven by changes at the facility and with an understanding of the importance of the safety at your offshore facility. If you feel that it's a low priority facility and that you can go with a longer period for updates, this is something you'll want to document in writing and make sure it's something that's auditable and you have a clear basis for that. As for any of these elements where you have a choice of the frequency of how often you update it. Every 3 years is a typical recommended practice in industry for refresher training and updating training for personnel. SEMP does not specify a period. It's left up to the operator. Again, 3 years is considered a typical best practice. Auditing the SEMS and SEMP elements. This is something that's already been identified. The original SEMP program had a 4-year interval. SEMS is going to require every 3 years, starting with the 2nd year after the completion of the initial SEMS program. Sounds complicated. It varies quite a bit. It's something that every operator is going to have to be very careful of to make sure things don't fall through the crack. Annual requirements, operating procedure updates is typically annually is a good time to do that. The frequency is actually based on the degree of hazard. SEMP does allow you some latitude for that. Emergency action plans, again, the period's unspecified. 1-year intervals are typically considered best practice. Also non-specific requirements, if there's a change in your design or operations, I'm sorry, mostly design, you'll want to update the safety and environmental information. If there's any change in design or operations, management of change may come into play. Safe work practices, mechanical integrity. Mechanical integrity is continuous. Every piece of equipment may have different frequencies where you want to be able to test, maintain, verify performance. These are all things that need to be documented and followed through as part of the mechanical integrity program. Pre-startup reviews, of course. These are things that are going to be associated with a startup, so there's not a specific period for it, but it's really easy to let those things slip, so it's very important to keep up with it. Incident investigation, hopefully you don't have to do this, but if there is a requirement, if you do have an incident, there's a requirement for prompt follow-up. So any non-incidental changes in design or operation may prompt you to go back to this evergreen program called SEMS and go ahead and bring things up to date. So let's talk about other things that can trip you up. The periodic requirement to update these programs is an easy way to be non-compliant. Other things that trip people up for the safety and environmental information are PFDs or PNIDs, missing, not current, or not complete, not properly filing, managing, or having the information available. The release system design basis. A lot of older facilities, especially if they've changed hands and ownership over the years, have lost a lot of critical information associated with release system design. This has to be made available. This has to be something that you can get your hands on. And also documentation of electrical area classifications. These are all things that can trip up or are key things that have tripped up folks with respect to safety and environmental information. Other sensitive areas for hazards analysis, for example, not getting your updates done on time with respect to the frequency that you specify at for your facility. Not closing recommendations. You're going to hear this multiple times. Not having an action item that comes out of some sort of safety evaluation and not following through with it is an easy pickup for a regulator to identify that you're not keeping up with your program, and also an easy basis for citation. So don't make it easy for them. Make sure any recommendations that come up are closed out. Not addressing human factors. Not using an accepted approach in terms of hazard evaluation. There's lots of ways to evaluate hazards out there. Recommended Practice 14J has a number of specific mechanisms that are considered acceptable. If you're not going to use those to the fullest extent that they require, you want to be able to document and justify why you're not doing that. Also, inconsistent consideration of scenarios and risk ranking. These are other things that can trip up and cause problems with your hazards analysis. Other deficiencies for management change, not using the procedure or the procedure not being current, and also not updating other portions of SEMS documentation to reflect that change. Other things that have tripped people up for operating procedures, not having the procedure up to date, not doing periodic reviews, we talked about that, not synchronizing the procedures with what the operator is actually doing, not listing key phases of operation, emergency shutdown procedure job assignments not being clear, not including temporary operations, and not including appropriate alarm set point ranges. If you've got an operator at console who can adjust the range, they want to know what the acceptable range is before they have to invoke management of change or get somebody to approve what they're doing. Safe work practices, poor training, people not knowledgeable in the procedures, not following through with logout, tagout, work permits, etc., and also not documenting and keeping records properly. These are things that can foul you up for safe work practices. Training programs, not documenting how the person who needs the training understood the training, not keeping that not documenting it in the first place, or not having the documentation available are key things that result in deficiencies with these programs. PPE procedures and training documentation not available, training records not showing how the employee understood the training, and also not accompanying maintenance procedures. These are all things that can foul you up with respect to your training program. Mechanical integrity, not having written procedures, not implementing them, not associated with the integrity of the process or having a basis for any testing or maintenance intervals that you choose. These are all things that can cause problems with your mechanical integrity program. Not following through with any requirements that you've already specified in writing. These are easy pickups for a regulator or if somebody's auditing your facility. Not correcting equipment deficiencies in a safe or timely manner. Relying on a contractor and not having a written program associated with that. And in general, not documenting mechanical integrity activities. These are all things that have fouled people up in the past. These are things that you want to look out for as you implement your SEMS program. Pre-startup reviews, not having a written procedure, not completing the documentation or keeping it on file, and also not documenting it until after you've actually started up, and then you do the paperwork later. It's just not acceptable in the current framework for SEMS. Emergency response and control. EEP is an emergency action plan, by the way. Not having that up to date, having phone numbers or contact points that are outdated, not having it usable, just being one big tome of information, not doing a periodic review, These are all things that can cause problems with the emergency action plan. With respect to training, not doing training on time, not doing physicals, fit testing for respirators, emergency response equipment that's not tested or maintained properly. These are all things that result in common deficiencies of SEMS programs with respect to emergency response and control. Incident investigations, not doing them thoroughly, not doing them correctly, not using a practice or generally accepted industry procedure for investigating incidents, not following through on recommendations, not sharing findings with employees, not promptly initiating the incident investigation, and not looking at near misses. And we'll talk more about near misses in a second. These are all things that have resulted in deficiencies in people's programs in the past. What's a near miss? This is something that's not well defined, and by definition, a near miss is something that hasn't really resulted in a major event. So a lot of people kind of let that go by. But you need to evaluate these just as for a major incident. If there's a tank gets full of liquid because you forgot to close a valve beneath the deck plate, relief valves going off and operators thinking that's acceptable for pressure control in a vessel, that's a near miss. Any sort of pressure challenge where you're approaching design limits are things that you want to evaluate, whether you evaluate it as part of a formal incident investigation or some mechanism for looking at root causes and addressing those. It's very important. Activating your emergency shutdown system or your blowout preventers, you know, if they are activated, it's probably trying to control something that's outside safety limits. It's not a preferred normal shutdown mechanism. These are things that you want to treat as a near miss and properly investigate. Other common deficiencies with respect to audits: lack of follow-through on recommendations. You'll hear that in about 3 seconds. Not doing the audits by the periodic deadline. The deadlines have been ratcheted down a little bit in the new SEMS program. Auditing the program, but not the supporting documentation. These are all deficiencies with audits not getting done properly. The most common program-wide deficiency that gets people into trouble with these safety management systems programs, just like SEMS, is addressing recommendations. You make it too easy for the regulator to go through and find problems with your program and cite you for them. So let's talk about some follow-through tips for recommendations. Assigning somebody to it. Just having a general recommendation out there that says, oh, somebody's going to look into this, that's just not acceptable. Putting somebody's name on it puts them on the hot seat, and it's more likely to get done in that manner. And assigning a target completion date to every recommendation. Leaving it open means it's going to get deprioritized with everybody's busy schedule. Documenting the actions taken. If you put effort into it, label it as closed. If you closed it out, or even if you went through later, and we'll talk about some justifications for getting rid of action items, even if you decided, hey, this is not important, we're not going to do it, document it, close it. Don't just leave it as an open item and try to explain it later when the regulator is sitting across the table from you at your facility in possibly a very unfortunate situation. Even if you perform all the actions, not documenting it can be a deficiency. You got to keep up with the documentation. So, how do you get rid of recommendations? This is an important area. Throughout industry, this is not an issue just for offshore facilities. Throughout industry, there are generally accepted practices for how do you justify not doing an action. Actions can come about through compliance audits. Actions can come about through incident investigations, through your hazards analysis. All these things can generate action items. Well, when you go about implementing them, you may get some new information. You may find they're not that worthwhile. This is what you want to document if you're just going to not do it. Don't just not do it and hope to explain it later. So one good reason for it is the analysis upon which the recommendation is based contains factual errors. People didn't have all the information up front, and they made a bad judgment. The recommendation is not necessary to protect the health and safety of employees and contractors. If it's not needed, maybe it could be deprioritized or not done. If you have another mechanism for doing that, that's another way to not do recommendations. Or if it's infeasible, if it involves a design function that just can't be achieved feasibly, that's something you want to document. So again, no matter how you do it, it's important that you do follow through and close these things out. So we just finished looking at a lot of the things that get people into trouble on SEMP and SEMS programs, and I'm trying to provide those to you for things that you can look out for to make sure that you look for these vulnerabilities and fix them for your SEMS program as it rolls out. What I also want to look at is another special topic to put things in perspective on the overall risk of facilities. What I want to do is have you keep in mind where these programs come from and focusing on the big picture issues with respect to what are your objectives for these programs. What you're really trying to do is you're trying to minimize the risk to the environment, to your personnel, when you're operating offshore facilities. The way to do that is to understand the nature of the scenarios that can cause problems and identify, are they high frequency but low consequence, in which case it may not be a big issue. If it's a very high consequence but it couldn't really occur, it may also not be very important. So by understanding the likelihood and the magnitude of the consequences, you can get an overall appreciation of risk. So the overall framework for what you're doing with these programs is trying to, first of all, identify potential hazards and have management systems or design features in place to minimize the risk by looking at both the probability and also the consequences of the event. I also keep in mind things change over time. If you're trying to keep risk consequence constant and consequences increase, then you need to decrease scenario likelihood. If you want to lower risk over time and the consequences increase, then the scenario likelihood must decrease even further. So the hazards analysis in this overall SEMS program, it's very important to look at risk and identify where you're at with respect to the programs and how your facility can impact other facilities, or, personnel, or the environment. And so what does this mean for safety system reliability for events involving large personnel consequences, large environmental consequences, or large impacts on ports, harbors, or shipping? You need to think about the reliability of the system when you put your mechanical integrity program together and the design of the system so that you can achieve the safety system reliability that's desired. There's a lot of safety features out there. There's a full range, a full spectrum of protection features, all the way from simple analog devices, things that use modern electronics, single end devices, multiple end devices, multiple transmitters, and evolving into voting logic. There's been an evolution of these over the past few years towards safety instrumented systems and high integrity protection systems. These are things that have evolved over time, but your safety systems really encompass a broad spectrum of these things. This is what you want to consider when you're looking at your hazards analysis and when you're evaluating the overall risk of the facility. These are not new concepts. In 1990, there was a platform safety shutdown system effectiveness study that was done that really set the stage, and there's a copy of a paper describing this on our website, and it really set the stage as analog devices were being replaced gradually by modern electronics and modern concepts to control risk. The idea for this effectiveness study was to look at that and identify where are the major elements that can contribute to problems with your protection systems and how to improve those. So the scope that was looked at the time were simple Type 1 platforms that were at the time offshore Nigeria, very complex Type 3 production platforms. Strafjord, Norway was the pattern for that. We looked at pneumatic systems, some of the newer electronics, a whole lots of different types of voting logic and fault-tolerant systems, and a lot of these were being evolved at the time. And what we came up with respect to findings were that dominant risk contributors were the end devices, your valves, emergency shutdown valves, blowdown valves, all sorts of things that needed to be activated by your logic processing unit, actuation signals that fed the control, the protection logic, and also the LPU itself, you know, whether it be analog, electronic, or otherwise, that could also be a contributor. Now, there's been a major evolution of this, but a lot of these concepts, a lot of what's out there really haven't changed that much. The end devices, the actuation signals, those do tend to dominate still. So what's been happening in the past couple of decades is really an evolution from the simple analog devices that may include mostly pneumatic equipment, all the way through electronic sensing and signal processing to voting logic. Now, in parallel to that, what you want to keep in mind is that there's been changes in guidelines for how to address those. With this offshore platform safety shutdown system effectiveness study was done in the late 80s and actually documented in 1990. 1996 came up with the first concepts of applying safety instrumented systems through ISA S84. That was updated later in 2004. And internationally, in 1999, IEC came up with similar guidelines for safety instrumented systems. Whether you call it SIS or HIPS, all these things are associated with providing high integrity systems that can properly protect your system. Also associated with that are specific reliability numbers for various pedigrees of these types of high integrity systems. SIL 1 being the lowest pedigree, the least reliable, SIL 3 being the highest reliability. Now, these three arrows on the screen are loosely coupled. What it's designed to do is show an evolution of what's been happening over the past couple of decades with respect to the evolution of protection systems, the design architecture specifications in terms of industry guidelines, and improvements in reliability over the year, because people have been lowering the bar in terms of what their risk tolerance is for a lot of these types of facilities. So let me try to pull those together. What you want to be aware of is that these requirements are out there. You want to find a way to factor those into how is your design, what is the risk of your facility, and what I wanted to share with you is that there are guidelines out there for this. So if you're starting to get a lot of questions from management about SIS, HIP systems, or how does this factor into safety integrity levels, there is a common ground here. They do all come together. And in fact, I'll be announcing another webinar that we're doing in about a month on showing how SIS, SIL, all these evaluation techniques also couple with your safety and environmental management system. Okay, so how do you evaluate this? Well, fault trees, for those of you who are familiar with them, they're very graphic, very detailed. They can very high-powered analytical technique, but it usually is often too high-powered for a lot of common applications. A lot of other folks are familiar with layer protection analysis. LOPA uses off-the-shelf data that's usually simplified to one significant figure to give you general idea of, is the system safe? Are you way off of your risk tolerance? And do you need to make major improvements in the design? What I wanted to share with you is the fact that these tools are out there to help you understand the overall safety risk levels at your facility so you can identify if your safety systems are adequate or not. What I want to share with you is there's a lot of overlap in these analytical techniques. When you're doing a hazard analysis of some sort using a HAZOP, what if, fault tree analysis, whatever you're using, that dovetails with this layer of protection analysis. It dovetails with the SIL assessment. It even is part of an overall framework of quantitative risk assessment. You're not just using isolated techniques. These all work together. And if you do it right, they can work together very efficiently. Now, what I also want to share with you to tie together this platform safety shutdown system, effectiveness study, the evolution of protection systems, safety integrity level requirements, et cetera, is just a reminder that if you're trying to lower the bar on what risk is acceptable to your operation, if the consequences are going up or you want to lower risk, you're going to have to really look at scenario likelihood. That's where all these SIL categories, the SIS and HIP systems come into play. All those are important to consider when you're looking into those issues. What that means is if you're looking at design guidelines, redundancy issues, the diversity of your system, what are acceptable design architectures, and also the overall reliability of your protection system, and folding that back into your mechanical integrity program that's part of SEMS, this all rolls together to try to make sure that the safety systems are operational and have sufficient reliability. Now, what that means is keep in mind that a lot of facilities have been designed using prescriptive standards. API Recommended Practice 14 series, for example, provides a lot of fairly prescriptive standards in terms of what's an acceptable system architecture. There may be occasions where you're getting questions about safety integrity levels or SIL values or these various SIS and HIPS systems where you need to go back and take a look at are these design guidelines that were in place when your facility was built, were they adequate, or do we need to take a fresh look at this and how does SIL come into play? Because I know a lot of the offshore facilities now are getting questions about safety integrity levels. This is really how it all fits together. Now, this is a very in-depth topic. We are going to spend a lot more time on this in a future webinar. I just want to share with you some basics for how all this stuff works together. But what I wanted to do next is, since we've looked at the evolution of protection systems, shown how that fits together as part of the SEMS program, looked at various common deficiencies in the SEMS program, and also what are the periodic requirements that can trip you up pretty frequently. What I wanted to talk about is what's going on with the regulations and some good news about resources that you might have within your own company. Basically, I mentioned earlier, and I showed that overlap between the various safety management systems. SEMS, SEMP, they're specifically for offshore facilities. TSM, RMP, they're for onshore facilities. But the majority, if you remember those overlapping circles, are common elements that apply to everything. And in fact, I'll show you a nice comparison table in a second. The good thing about it is if you're part of an offshore company that has onshore business units, you've probably got a lot of resources in-house to draw upon. If the BOEMRE is going to enforce a one-year time period for a SEMS implementation, you've got a lot of work to do. So you want to be looking for resources, and you may already have some in your pocket. Obviously, there's a lot of consultants and a lot of other specialists that can help out. We're part of that pool of resources too. But if you're an operating company that's got onshore facilities, chances are you've got a lot of resources internally too. This is just a handy reference table for you showing some of this overlap if you're trying to communicate with some of your onshore business units. And what I wanted to do is share with you what we'd consider a recommended strategy for how do you roll out safety management system programs like SEMS. First of all, recognize that there's a broad spectrum of activities. This is not simple. SEMS impacts every aspect of how you manage your operation at your offshore facility. You want to go through and review that. Carefully document if you're doing too much. Find out where the gaps are. What you want to do is try to integrate all these different activities, minimize duplication. If you've got an active SEMP program or you've got other elements in place, weave those in first to your SEMS program and take a look at what you got, look for gaps, and then as necessary go back and enhance it. Don't go in there and say, oh, I start SEMS program with a blank sheet of paper. Chances are, if you've got an operating facility, you've got a lot of these elements already addressed. Go ahead and find the stuff that you've already got, what exists, get it assembled, then take a look for gaps, and then really focus your efforts on the areas that need improvement. Don't just assume because SEMS is maybe a new topic for you or your staff that everything needs to get started afresh. Chances are you've got most of these, if you've got an effective operating offshore facility that's working, that's reliable, that's been safe, chances are you're doing a lot of these things. It's a matter of compiling this and assembling it in terms of an overall program. But I do have a word of caution. That's the last bullet on the page. Don't wait or don't hesitate too long to get these things started. A year goes by fairly quickly, and it requires a lot of resources and cooperation of multiple departments within your organization, and you may need some outside resources too. So anyhow, let's talk about resources. I mentioned this as part, for those of you who this is not your first time for this offshore webinar series, we are offering these on a rotating basis. These are, the ones on the screen are examples of one we've done recently. It covers a full gamut that we've had guest speakers, regulators, and other specialists in some of these safety management systems elements. These are all available by video if you'd like to look at any past items. And also we've got one coming up if you're having to deal with hazards analysis, HAZOP studies, LOPA, SIL assessments, PIP systems, safety instrumented systems, you're going to really want to tune into November 14th. We're going to cover a lot of those in a lot more detail than I've had time today. So also what's happening, for those of you who have the ability to travel to Southern California, the State Lands Commission sponsors an annual symposium focused on offshore facilities and offshore facility safety. It's called Prevention First. That's happening next week in Long Beach, California. Risk management professionals doesn't have anything to do with that other than we're an invited speaker at the symposium, and we're running a little exhibit. This is something that's put on by the State Lands Commission. They do charge, and the web address is on the screen and in the handout materials that were sent to you yesterday. Also, just for your reference, I've got a lot of this background information spelled out, so you can Google it, find it pretty easily, and of course, if you have any questions when you're going through this, give any of the staff here a call. I'm Steve Maher. Esther Brawley and Carlos Cheek have been working with me to put the presentation together. They're basically off-site today helping folks out. So anyhow, if you have any questions, feel free to call any of the staff here. There's our toll-free number on the screen. Also, you can find us pretty easily on the web, too. So with that, I will open it up to questions. Okay, well, either I did a really great job or I went through it way too fast. For everyone. Yeah, I guess it is early for some folks. Okay, cool. I'll hold for a couple minutes. And I'll get a cup of coffee. That's a great question. That has not been defined yet. Oh, okay. Oh, okay, good. The question was, who is going to be auditing these SEMS programs? Right now, the details have not been specified. What they have identified is in fact, I don't know if I can go to the first slide really. Oh yeah, can you go to the first slide or back up? I'll just back up a bunch while you back up while I answer the question. The words on the from the BOEMRE were fairly loose. In their September 30th press release, they basically just said that independent third-party verification of operator SEMS programs were going to be part of a future ruling. Now, I listed that as a potential requirement. Sooner or later, for all these safety management systems programs, so you're talking about PSM, RMP, SEMP, or SEMS, somebody is going to look at the program and audit it to get a read on how successful the program is and how well it's being implemented. Right now, reading the words from the press release, it seems to indicate that the BOEMRE is going to realize that they may not have the resources to audit all these programs, so they're going to simply require that a third party, so a consultant like us, risk management professionals, would go through and audit these programs. By the way, there's lots of other folks out there that can also do these audits capably, and that BOEMRE will just ensure that the audits are being done. Now, the audit, I would suspect they're going to want to buffer their own resources, their own expertise, and also do some degree of auditing too, and also it's their responsibility for compliance. So, very speculative at this point. That's where I would see it going, is the prevalence of independent engineering consultants. Please make sure that you get somebody with the right background so they know what they're looking for, and don't overdo it, and don't miss things that are important and possibly even obvious. But get qualified individuals, get it done right, and I suspect the BOEMRE is going to want to be looking to make sure that was done, checking the qualifications of the audit, and maybe even asking for a submittal of the audit reports. With respect to submittals, that also is unclear. The SEMP program has been self-documented with the materials remaining at the offices for the offshore facility operator. Right now, they have made any mention in the fact sheets and some of the initial information that they're going to require submittal. I kind of would guess that they'll follow through with that, but that they'll want to be auditing these documents and maybe even asking for copies of the specific third-party audits.
Sure. Okay. Until these rules are finalized, can they hold you to a general duty clause as far as having program elements?
Well, that's a good question. I'm sure they can. I don't know the specifics of that. And until the rules are finalized, that's something should probably be resolved over the next couple of weeks. And with respect to general duty, I'm sure that they'll go through, and if they're not going to be, I don't see them doing a lot of inspections. Here's how things typically roll out. I can't see them doing a lot of inspections for facilities. There's just not enough manpower. But if you're unfortunate enough to have an event, or if you're on their radar screen for maybe spot audits or spot checks, and they find problems that they feel is outside the context of doing safe operations, I'm sure that there'll be some consequences associated with that. And so I know I'm not addressing the question as specifically as I'd like to. There's a lot happening right now, and I can probably give a better answer after the regulations come out. And what we're going to do, too, for the upcoming webinar in November is any new clarifications or things that happen, we're going to be spending a little bit of time with that. In fact, if there's a lot of changes with respect to SEMS requirements or a lot of specifics that we need to communicate, we also may shift the topic of the November webinar, too. Okay. All right, well, yeah, thank you for attendance. Please feel free to call us if you have any questions, and I hope you guys can tune in November.